It's been predicted that in 2025, the world will generate nearly 480 million terabytes of data every day. That's 175 zettabytes per year. To put that into context, it's more than 3.5 times what we produced in 2019. And yet, despite having access to more data than we've ever had before, Gartner estimates that poor data quality costs organizations an average of $12.9 million a year. Meanwhile, poor data engineers are spending as much as 80% of their time just trying to massage data into a format that systems can use. And to make matters worse, they're usually cleaning up someone else's mess rather than their own. So, what's happening here? Why is it so hard to make all of this data useful? Joe Reese, the co-author of Fundamentals of Data Engineering, captures this in a blog post when he says, business case, then tools, never the reverse. Too often, teams do this in reverse, making technology or architecture decisions without really understanding what the business needs. This can force them to bend their solutions to fit the chosen technology or architecture. And the end result is building something that doesn't really match what the business needs. It's critical when building any kind of software, but especially data pipelines, to understand the business case before deciding on tools or architectural approaches. We're going to explore some of the trade-offs engineers have to evaluate throughout the data lifecycle. However, keep in mind that it's critical to understand the business case first so we can make the right decisions. So what is the data engineering lifecycle? It breaks down into 4 key stages. The first is data generation. This is the origin of the data, whether it's coming from users, sensors, or other systems. Once it has been generated, it needs to be ingested into the data pipeline where it can be processed. And after that, we begin to transform it. This is where we're taking it from the raw format and converting it into something that will be more useful for analysis. Finally, when the data is ready, we serve it to the people and systems that need it. Each of these stages has hidden challenges that we have to account for during the process. So let's break down what those challenges are. Data generation is the first stage in the lifecycle. This is where the system connects to the outside world and generates data based on those interactions. This could include humans clicking through an e-commerce platform, IoT sensors reporting temperature readings, or application logs that capture user behaviors. Here, the data challenges are often quality related. Users can enter invalid data, sensors can malfunction, and system logs can be incomplete. As engineers comb through this data, they're faced with a critical decision. Do they push back on the teams generating the data to make it cleaner at the source, or spend resources cleaning and validating it downstream? We should always try to improve the data as close to the source as possible to allow downstream users to take advantage of the improvements. The further away from the source we get, the more difficult it becomes to correct the data because we've lost the context of where it was created. We are also more likely to duplicate the cleaning and validation logic. And let's face it, the people with the business knowledge required to correct the data are likely going to be the ones who created it. Of course, this assumes there is a measure of control over the origin of the data, which is often not the case. If the data is outside of our control, or cleaning at the source is too difficult, we'll have no choice but to fix it once it enters our pipeline. But don't wait too long. Cleaning bad data downstream can be far more costly than fixing it near the source. Ingestion is where the data engineer takes control as the data is moved into the processing pipeline. This often happens with minimal transformation being applied to ensure we can always go back to the original data if necessary. However, a critical transition often occurs here. Although the data in the source systems is typically being generated in real time, frequently it's imported into the data pipeline using batch processes. Essentially, the pipelines are waiting for data to accumulate into time or size-based batches before they begin processing. This fundamentally changes the nature of the data and creates another trade-off. Batching has clear benefits. It's often easier to write and can take advantage of certain efficiencies. However, the costs are significant. We lose the real-time nature of the data, insights take longer to arrive, and pipeline failures can result in reprocessing entire batches. The reality is that in the business domain, events are occurring in real time. It's very rare that a business has data that legitimately occurs in batches. Many organizations start with batch processing simply for convenience, but the reality is that real time is more competitive. With that in mind, whenever we have to make a decision about whether to use real time or batch, we should ask ourselves whether this process can give us a competitive advantage. If it can, especially if it results in direct revenue, then we should default to using real time. We can always fall back to batch if we're forced to, for example, if we are reading from a legacy system that doesn't support real time. The transformation phase is where the real business logic lives. It's where we take the raw incoming data and transform it into something that will be more useful for the business. This could mean performing aggregations, changing the data structure, and cleaning invalid values. The challenge is that this process may require multiple transformations to prepare the data for consumption. Each transformation potentially introduces a bottleneck or a point of failure in the pipeline. This leads to another critical trade-off. When dealing with issues that span the entire pipeline, it's often easier to understand and debug them with a monolith. However, modular approaches tend to be more reusable and can be easier to understand individually. And so we have to decide if we build monolithic transformations or modular ones. When businesses are young, it often makes more sense to build using monolithic processes. Early on, they tend to be faster to develop and require less complex deployment and monitoring strategies. In addition, the developers may be figuring out what the domain looks like and will lack the expertise to understand how to properly modularize the software. However, as the business matures and the data needs grow, this monolithic approach becomes more expensive. Code and data may be duplicated across different transformations, which increases processing and storage costs. Meanwhile, failures in a monolithic architecture tend to be more costly to recover from. So, as the business matures, switching to a more modular approach is often a good idea. The final stage is serving, where data is placed into a form that can be consumed by those who need it. We can serve data through data warehouses, lakes, or lakehouses. Just keep in mind that these often sacrifice the real-time nature of the data in return for giving us something that is highly queryable. Alternatively, we can expose data through APIs for programmatic access with controlled interfaces. Or we can use streaming platforms like Apache Kafka, which can help maintain the real-time nature of the data, often at the cost of being more difficult to query. This creates yet another trade-off. Do we keep data in motion where systems can react to it immediately, or do we drop it somewhere static where it's easier to query and analyze? Part of this depends on what we did upstream. If we're using hourly batches to pull in the data, then we've already given up the real-time aspect, and trying to maintain it here won't make any difference. On the other hand, if we've put effort upstream into maintaining the real-time data, then it would seem foolish to give it up now, which raises an important consideration. We can always take real-time data and funnel it into a static data store to help us query it. However, once we've lost the real-time nature of the data, we can't get it back. Therefore, whenever possible, we should start with real-time data and convert it to static data only when necessary. There's another popular way to think about data pipeline stages called the Medallion Architecture. It assigns specific phases to categories based on Olympic medals, bronze, silver, and gold. The Medallion Architecture breaks the pipeline into 3 unique layers. The bronze layer corresponds to raw data ingestion. This is where we bring data into the pipeline, applying minimal transformations in the process. The silver layer is a transformation where data gets cleaned, validated, and enriched, but without significant aggregation. We are modeling the data independently of specific business cases, keeping it flexible for multiple uses. The gold layer is where we model data for specific use cases, applying aggregations to create business-ready insights. Sometimes that means creating multiple views of the same data, each serving a different purpose. Data can arguably be served from any of the layers, however the gold and silver layers are typically the primary targets. Each layer has different characteristics and represents different trade-offs in terms of data quality, processing complexity, and consumer readiness. The bronze layer maps directly to the ingestion phase we discussed earlier. Here, minimal transformation is applied to the incoming data. We're just getting it into our system. Data in the bronze layer is typically not being consumed by business users or analysts. The key principle is preserving the original data structure and format as much as possible. The value of this approach becomes clear when we need to make changes downstream. We always have the original data if we need to reprocess, add new transformations, or fix errors in our pipeline logic. This is our safety net, our source of truth for everything that flows through the pipeline. The silver layer maps to the transformation phase, but with a specific focus. Here, transformations focus on cleaning, validation, and importantly, data modeling. In other words, creating structured data that is reusable across the organization. This is where we apply consistent, reusable formats that make it easier for analysts to combine data and perform analysis. We want data that's higher quality than bronze and properly structured, but still preserves the original granularity and detail. This creates an important trade-off. The effort invested in proper data structuring increases processing complexity and development time, but dramatically improves downstream reusability. Silver data serves as the structured foundation that both gold layer processes and direct analytics can build upon. The gold layer is where data becomes business ready for consumption. This is where aggregations have been applied for specific business cases. The fundamental trade-off here is that we're accepting a loss of detail in exchange for insight and usability. Gold data is optimized for the specific business questions that analysts and stakeholders need to answer. When it comes to analytics, both silver and gold layers are commonly used. Silver provides the detailed, structured data that analysts need for exploratory work and combining different datasets. Gold provides the pre-aggregated insights for dashboards and standard reports. This dual-layer approach gives analysts flexibility. They can use silver when they need granular data to explore and combine, and gold when they need fast access to high-level performance indicators. The existence of these layers can depend on how we have architected our pipeline. The Medallion architecture is really geared towards extract, load, and transform pipelines. Here, data is loaded into a data lakehouse immediately prior to transformation, and that becomes the bronze layer. In extract, transform, and load-based systems, transformations often happen before the data is loaded, and as a result, the bronze layer may not exist at all. Finally, let's consider how streaming versus batch processing affects the entire lifecycle. In batch implementations, the bronze, silver, and gold layers are typically datasets stored in a lakehouse. The advantage to this approach is that it gives us static, queryable data that's easy to analyze and understand. In streaming implementations, each transformation stage results in another stream of data. The advantage to streaming is that it maintains the real-time nature throughout the entire lifecycle. This enables reactive, event-driven architectures and reduces latency between data generation and insights. So let's come back to our original question. Why is it so hard to make all of this data useful? The answer lies in the trade-offs at each stage of the lifecycle. Every decision we make, from how we handle data generation to whether we choose batch or stream processing, involves sacrificing one benefit to gain another. A skilled data engineer has a strong grasp of the trade-offs and what they will cost. If they understand the lifecycle and make clear and intentional decisions at each stage, they can reduce the overall cost of poor data quality and avoid wasting precious time. The key insight for the data engineer is to understand the needs of the business and balance the trade-offs to ensure the data pipeline fits the domain rather than just falling back to what's easiest or most familiar.